3.3, absolute value equations and inequalities. Well, let's review a little bit of absolute value stuff. So absolute value is just the distance a value is from 0. So you notice right here, the absolute value of -5 is 5. The absolute value of 5, it's the same value because distance, we never refer to distances in the negative. So it'd be weird to be like, I live -80 miles south of here. Like, okay, now if you're trying to trick people, I get it. And if that's you, you'll make a great politician someday. But we don't usually refer to distances as in the negative, right? So that's what this is saying. It's a distance, never comes out a negative. So it's not an opposite thing, which some students mistake on this one. They'll say the absolute value of 5 is -5. No, it's not an opposite thing. It's a distance thing. So that's why both of these are positive. And of course, it doesn't matter how large these numbers are. It's always asking the real question, how far away from 0 is that value? That's some review, but for equations, what we end up with is some kind of absolute value of x, okay? So as an example, which I'm going to do fairly quickly, the absolute value of x we'll say is 10. 10 is a very easy number to work with. This is asking the question, this will work, there we go. What value, and I'm purposefully putting in the s, what values are 10 away from 0? Question mark. Yeah, that's exactly correct. Two answers, 10 and then the -10, right? Now I'm not going to do it with the number line. You can go 10 away to the right, 10 away to the left from 0. These two numbers are 10 away from 0. Now, of course, we'd say, well, that's what x equals, but you notice there's two answers, which is a little different than most of the solving equations that we do that have one variable, but this one has one variable, two answers. You'll notice that when I start solving these, what I like to do is split these up like this, and then one would represent, so you just say, well, what's inside the absolute value? Then it equals whatever's on the other side, so in this case 10 and then -10. Then you solve from there. Of course, there's no solving here, but we probably will here. Now, on the other hand of this is solving what we call literal equations, meaning that if there's anything on the outside of this absolute value, you have to get rid of that stuff with principles of equality, either forcing values to be usually zeros first and then ones. That doesn't have to make sense. We're going to see it. And then we'll solve. Essentially, it becomes kind of like three equations to solve. So you solve first for the absolute value, and then down here, usually there's something to solve for as well. Now, here, this one is kind of crucial. If your absolute value of whatever this is, as long as there's an x in there, if it equals a negative, that can't ever happen because we don't refer to distances as negatives. So if you see that, let me give you an example. So if it said the absolute value of x plus 15 equals -4, right here, right there, you don't have to do any more. You're done. There's just no solutions for this one. There's no value that I can put in there to make it come out as a negative distance. Now, again, you'll notice here, even the way that I have this is forced the absolute value to be by itself. So if there was like a 4 right here, I'd divide both sides by 4, and then I could say that. If I made this a negative, I would divide both sides by -4, which isolates the absolute value, and then I would be able to solve from there because on the right side, -4 divided by -4 is 1. Again, that doesn't have to make perfect sense right now. We'll see examples that cover that. So we'll solve. If there is more than one solution, separate them with a comma. Fair enough. And we'll even check. We'll even check with these, but I'm going to use the calculator. So here's another thing that some students do that cause problems. And if you do it, it's likely to cause problems for you. Because some students look at the absolute values as though they are parentheses, which they're classified in the order of operations with parentheses, but I can't operate inside there, so it's different, okay? Here's what I'm talking about. If you do this on an exam, you may set yourself up for a disaster. Now, if this 6 right here is positive, so it actually wouldn't really make a difference. I'm just going to encourage you to avoid that altogether. Get rid of all the other stuff on the outside, meaning, even right now, I don't really care what's on the inside. Oh, crap. I really don't care what's on the inside. There we go. Right now, don't worry about the inside. Get rid of the stuff on the outside. And by get rid of, I'm talking about principles of equality. So right here, first thing I would do, this is a full term. I'd like to just be able to drop it, right? So it's 6 times the absolute value of something. It's that -5 that I got to make go away. And by go away, I mean become a 0. So add 5 to both sides. So the principles of equality we're using with purpose. We're not just adding random values. We're doing this to force a 0 to occur, which we've just done. And then this would equal -11 plus 5, which is -6. Okay. I see what's happening now. Now, you notice again, I'm not worried about the inside of the absolute value. You could write it in if you wanted to. It's just not necessary that you do. The last thing I want in this problem is for the absolute value to just be by itself, meaning I'm going to force that 6 that's multiplying the absolute value to become a 1, because if I do that, I can make it a phantom 1, and I don't have to look at that garbage. So how do you do that? You divide both sides by 6, and I hope none of... Now, yeah, so I'm using division. I'm going to say something which may cause confusion, so if it does, ignore it. You could multiply it by 1/6, but I don't know why you'd do that, other than to just be a smart aleck math person, which some people like. -6 divided by 6 is -1. Now again, do we know what's on the inside of this? No, I don't really care, but it's done. Why is it done? Because right there we got the negative. It equals, an absolute value is equaling a negative distance. That can't happen. Right here, there's just no solutions. But again, I waited until I got the absolute value by itself. Some students, they stop right here and they say there's no solutions because this is -11. Well, there's other stuff here you got to get rid of first. Okay, so we got rid of the -5, we got rid of the 6, and there's the 1 if you want to see it. Does it matter what's on the inside there? It doesn't. It doesn't matter what's on the inside of that absolute value. All right, so here's another one. And again, this is not where you stop, because some students in the past on an exam, a question like this would be worth like 5 points out of 100. And you say, well, it's negative right there. And they say there's no solutions. No, you can't say that yet. You need to finish this. Well, so don't stop here. Don't say, well, it's just, it equals a negative. There's no solutions. Don't say that. And also on this one especially, now if you were to, by chance, want to distribute, you'd be distributing this -6, which that's going to screw things up. Okay, so don't distribute. Never distribute with absolute values like you would with parentheses. You can do it in some cases, but this is not the case that you should really never do it, but either way. Okay, so we're going to principles of equality. I'm going to zero out that positive 12 by subtracting 12 from both sides. And again, that's to force that to become 0. Now I got -6 times the absolute value of 3x minus 4. I'm trying to emphasize those absolute values so they don't look like 1s. And -36 minus 12 is -48. And now, even here, some students say, well, that equals -48. That can't happen. It can, because now at this point, we're going to divide both sides by -6. See, and that's going to become a 1, and we're just left with the absolute value of 3x minus 4. I'll make that a little bit bigger. And -48 divided by -6 is positive 8 now. Okay, so this now is positive, and that's good. That will work. So we can solve this. We should be able to find some values that work here. And like I was saying before, for me, this means that I'm going to take these and I'm going to split them up. Okay, so I know it's a distance from 0, and it's going to be a specific distance of 8, right? So that means if I could get the 3x minus 4 to equal positive 8, I can get a true statement. Now this 8 right here that I just put down there, it's not specifically this 8. It would go inside the absolute value, because that's what it's a replacement substitution type method right here. So when I solve this equation for an x, it's an x that's replacing this one, and then when we solve it, it should end up being this 8, right? An absolute value of 8 is 8, and that would work. But also, if I could make that inside of the absolute value, 3x minus 4 to equal -8, it would still be true. Okay, and again, this -8 would be on the inside of that absolute value after solving for x, and the absolute value of -8 is 8. That's why we end up with two values on this. So let's go ahead and solve them. So first up, and you'll notice that it's actually the same principles of equality on both. I'm going to only do one at a time though now. So that's going to zero that negative 4, drop the 3x, now equals 12. And then divide both sides by 3. Hope you had more space than I did, but 1x, phantom 1x equals 4. Okay, now let's just check, right? 3 times 4 is 12, which was part of our work. And then minus 4 ends up being that 8. The absolute value of 8 is 8. So that's true right there. And if you wanted to, you could box that in, but it said it wanted commas to separate the answers, whatever. So here's the next principle of equality. Let's make that negative 4. You see how it's plus 4 again? To zero out the negative 4. So now 3x equals negative 8 plus 4 is negative 4. Looks like we're going to get a fraction on this one, which is going to be great. Divide by 3. I'll show the division a little different, but that's 1. 1x equals negative 4/3. Now let's put negative 4/3. Again, it's replacing the x. It's not saying the absolute value is a negative. Take 3 times it by negative 4/3. That'd be negative 4 minus 4 is negative 8. Remember, that's what we were trying to get here. Absolute value of negative 8 is 8. So that works as well. And I'll box that in with some fair confidence. I was trying them up here. I actually should have been trying them up here, but it would still work. I apologize. I will write the solution. So on the homework, of course, it's going to say something like x equals, and it's going to give you a box. So you type in 4, and it doesn't matter which order you put these in, 4 comma, and then negative 4/3. I don't know. That's good. So right here on this one's a little different, but we did see that on that other slide. I just didn't really go over it very much. So on these types, they're actually not so bad. What we're going to end up doing is we're going to treat this second absolute value like it doesn't exist. And the reason why that is because the distance from 0 is the distance from 0 no matter which side you choose, okay? So this side's distance from 0 is exactly the same as this side's distance from 0, positive or negative. So it doesn't matter which one you choose. I mean, you could do this technically 4 times, but it's not really going to help. Here's what I mean. Is I'm going to take my negative 3x minus 1, because I always use the one on the left, and I'm going to split this up, okay? So I'm saying if I can get that negative 3x minus 1, if I could get it to actually just equal what's inside the other one, just the negative 8x plus 7, I'll get a true statement out of it. Okay, so that's one equation that I will end up solving. But the other one is where I take the negative 3x minus 1, but now it's going to equal the opposite of negative 8x plus 7. Now, I'm setting it up like this because it's it corresponds to what we were doing with like the 8s, right? You got one's positive, one's negative. Here's my positive, here's now my negative. But it's the whole thing that's negative. I need to make the whole thing negative. I like to show this step. Some students don't, and so they'll just say, all that means to me is I'm going to change the signs. Okay, that's fine. In fact, let's go ahead and do that right now, because the way that I have it, you'd be distributing a negative 1 into the parentheses here, right? So negative 1 times negative 8x's would be 8x's. See how it changed the sign? And then also negative 1 times positive 7 would be negative 7. So it just changed the signs there, but it does not do anything to the first equation, all right? Now I have 2 full equations. There's no more distribution, no more combined like terms. You're just going to solve it like you would a regular equation with principles of equality. I'll stick with that one on the right just because I already did some work with it. So let's stay there. So for me, I'm going to put my x's on the left, numbers on the right. You don't have to. You can switch them. You just need to end up with the same answer because it doesn't matter which side the x's are on. So that negative 1, I'm going to have to zero out by adding 1 to both sides. And that will zero that out. But also the 8x, I'm going to have to zero that out because it's on the number side of things, but it's an x term. So I'll subtract 8x's from both sides too. So what are we getting here? That zeroes out. Negative 3x's minus 8x's would be negative 11x's, which equals negative 7 plus 1 is negative 6. And then finally, we'll divide both sides by negative 11, which tells me that x would then be 6/11. Okay, well, there's one solution. We'll come back here, but I just want to check this. Okay, so I go to my calculator. On the left side, I've got negative 3 times 6/11 minus 1, enter, and my calculator gives me, from that, it gives me negative 2.63 repeating. Okay, now that was the left side of the equation, so I'm going to try the right side. Oh, but that was absolute value. So actually it was a positive in the end. So negative 8 times 6/11. I can type it in right, plus 7, enter. And yeah, it ends up being the same value. That right side, though, is positive on the inside of that absolute value, but it is the same value. It's the same absolute value. Okay, so that's true. Since it is true, I know this is one of the solutions. Let's see if we can find a second one. Well, let's start on this next one then. So same idea. I'm going to put my x's on the left, numbers on the right. So the negative 1 will be zeroed out by adding 1 to both sides. So that will zero out. But the negative 8x, again, it's on the number side of things. We'll have to add 8x's to both sides to zero that out. So on the left side, negative 3x's plus 8x's would be 5x's. And then on the right side, 7 plus 1 is 8. And then last of all, we just want this to be a coefficient phantom 1 and divide both sides by 5 to do that. Okay, so there's my 1. X then equals 8/5. That's fully simplified. You can have the decimal if you want it. It's like 1.6 if you care. But again, let's go back up to the top and let's replace this x's with 8/5. Okay, so I got negative 3 times 8/5 minus 1, enter. And on my calculator, give me the fraction negative 29/5. Okay, now does it? That's the left side. The absolute value that would have been positive. Now negative 8 times 8/5 plus 7, and that's negative 29/5 as well. But again, the absolute value that would have been 29/5. So this also is a true statement. So as strange as this seems, I guess there wasn't any mistakes there. But there's our two answers. So again, on the assignment, you just list these, type in 8/5, comma, 6/11. Doesn't matter which order you put them in, just put a comma between them. So this graphing stuff right here is kind of telling us how the setup is going to occur for us to solve. If the absolute value, again, this is showing x, but it could be like x plus 5 or negative 3x plus 15, something like that on the inside there. It doesn't matter what's on the inside here. The absolute value of this, if it ends up being less than whatever value is over here, it ends up being sandwiched between those values. And the reason that is, we'll pretend like I'm doing this good, it's because it's a reflection, right? Because we know everything to the right of this would be true, 0 to whatever the value is, and so the absolute value tells us that it has to go to the opposite of that, which would be the negative value as well. So we end up with this being sandwiched. Right. This one is an and statement right here. This one is the or statement. So if you end up having the absolute value, again, doesn't matter what's on the inside there, if it's bigger or greater than whatever value you're comparing it with, it ends up being an or statement. Because if let's say that the absolute value wasn't there, well, you'd have the value and then everything to the right of it, right? But now we're saying that it kind of reflects over the 0 over here, and now everything, because the absolute value of this stuff is also going to be bigger than whatever the actual A is. I suppose that doesn't have to make a lot of sense right now, but this is going to help us set these up, okay? Because we need to know if are we going to set up an and statement, or is it going to be an or statement? And this and statement right here is just, it's a triple inequality, a compound inequality, however you want to say it, but it's sandwiched between. Here we actually do need the or statement. So in the past, the equations that we were solving, that's what this is demonstrating. So if you have the absolute value of something equals some number, then you have it could equal the number, but it could equal the opposite as well. So now we can kind of relate that graphically to the inequalities. Last thing I should mention about these is we have to go back to solving regular inequalities. When solving, because we're going to need to do that, right? When solving inequalities, there was one extra rule that we have when we solve inequalities, and that's right, like in creating zeros and ones. It says when you multiply or divide both sides, so we're talking about the multiplication or division principles of equality, both sides of the equal sign with a negative, and I think we've seen this, that will flip the inequality. Sorry, this is a manifestation of my poor typing skills, but it sounds like I'm going fast. I'm just pressing delete a lot. Let's see what we got right here. So we'll give the answer in interval notation, no problem, but let's give ourselves some space. So an inequality, don't separate it like we saw on that last slide. Don't worry about making an and statement or an or statement until you get to the inequality. All right, so this one, principles of equality, right? And we know the addition and subtraction principles of equality do not affect the inequality. So whatever I do here is going to still be a greater than symbol because I'm just going to subtract the 2 from both sides, okay? And again, that's to just zero that out. So then I got 4 times the absolute value of x plus 5 is greater than 11 minus 2, which is 9. I really wish it was 8, but here we are. Okay, now this principle of equality is going to require division because I don't want the 4 there, right? So I'm going to take that 4 and divide it by 4, but if I do it to one side, I've got to do the other side. So that's going to leave me with just the absolute value of x plus 5. And if there's a phantom 1 there, I just don't want to show it, and I hope you don't either. But I divided both sides, which is, we need to remember that, right? If we're dividing both sides by a negative, we would flip it. But I divided both sides by a positive, so it will remain a greater than symbol. It just happens to give us a fraction, which may make us not so happy. But we can deal with it. All right, now that I have that, what I'm going to do is I'm going to take my inequality, my absolute value, I should say, and I'm going to split it up again, okay? There we go, technology. So the first one, we just kind of rewrite the inequality. We say we're going to take the x plus 5 and make it greater than 9/4. So just like we did with the absolute value equations, it just stays the same. The first one, for me, stays the same. That's a positive 9/4. But the other one, we'll compare x plus 5, and just like the other equations, now I'm going to compare with 9/4. But because I'm now comparing it with its opposite, the absolute value is going, or the inequality is going to flip there. So like we saw on the last slide as well, right here, hopefully we were expecting this because it was eating the absolute value, or the absolute value is greater than the number. So this is actually an or statement, which we would need. And yeah, some of you guys would like to prefer to just put the u there. Either way, it's both of those are or statements. So now I've got 2 inequalities that I need to solve, and only one principle of equality needed. So this one right here, we'll subtract 5 from both sides. And then x, again, subtraction won't change your inequality there. Geez, that's going to be negative. Okay, that's going to be negative 16. Thank you. I did that wrong in my head, which is
negative 11.
See, it's my. I like to see the calculator, but yes, negative 11/4. I didn't quite get there. Over here, though, we're going to subtract 5. I think I can do this one. Negative 34/4, so negative 17 halves.
Minus 29/4.
Well, that's a good example, again, of why you should use a calculator, which I did not do.
You see the soundtrack there.
Now, yeah, thank you. That's, thank you. Okay, so this, by the way, is the inequality. Remember to put an or statement between those when you solve for it. By the way, if I do not see the or statement on the exam, I would have to take a point off.
I think it's 29/4.
29, oh. That's because it is. Yeah, okay. Hey, I've only got 2 on this problem so far. I got a bundle left to go, so Okay, so we do have this. We do have the inequalities. Let's put together the number line then. Oh, one's positive, one's negative, so that's good. I'll just put negative 29/4 over here. And then 11/4 over here. I know it's not scaled. I also don't give a crap. So,
I'm sorry.
let's fix that because it is negative 11/4, which is bigger than negative 29/4. I still got both values on there, so I feel good. Okay, so I'm starting with the green one. That's going to be, it looks like greater than or equal to, but it's just greater than. So it's going to be an open circle at 11/4. It's eating the x, so it should go to the right. And then the negative 29/4 is still an open circle because it's just less than, but this one's not eating the x, so it goes to the left. So with a little bit more space, but you should be able to get the interval on here. So the orange line goes all the way to negative infinity. I like to move my way from left to right. It stops at negative 29/4, which is not included. And then we will unite that starting at negative 11/4 for the green. This one goes to infinity, and the infinities are never included. So that should be our interval. And here's what the interval tells us, okay? It's a nice way to tell us the same thing that the graph does, which is any values that are on or under the lines, however you want to say it. The lines cover any values. If you were to take any of those values and replace the x there with any of those values, so there's actually an infinite number of solutions, right? You can replace that x with any of those values, and you'd get a true statement from this inequality. So this one also, just like the last one, it's eating the absolute value. And so when we split this up, it should end up being an or statement again. So this one, the inside of the absolute value, right? We got x plus 6 divided by 2. And I'm just going to compare this with just positive 3, but if I compare it with a positive, it's just going to be the regular inequality, the greater than or equal to symbol. Again, I know that it's eating the absolute value, so I'm going to put my or statement there right now. And then the other part of it is where we take the inside of the inequality, x plus 6 over 2, and we compare with the opposite of, in this case, 3, which is negative 3, but by doing so, we need to flip that inequality. So for this one, we are expecting the 2 lines to go away from each other, like the last one that we just barely did, and we're expecting an or statement, a union statement on this one. Is it going to be? I don't know. Let's find out, though. So on this one, well, for both of them, actually, I'd multiply both sides by 2. That's going to make that a phantom 1. That leaves us with just the numerator. X plus 6 now is greater than or equal to 3 times 2, which is 6. And one last principle of equality, to zero out this 6, drop my x, which is greater than or equal to 0. Now some students say, well, it's greater than or equal to 0, so there is no solutions. No, 0 is part of the solution right there. We're saying x, it could be equal to 0, but it could also be greater than 0. So that's our first inequality. Let's look at the next one. The process, you'll notice, just like we saw before, ends up being the same on both sides, right? So that's when it's going to make that a phantom 1 right there. And now I've got x plus 6 is less than or equal to negative 3 times 2 is negative 6. Now, I should point this out. See on these 2 here, how we multiplied both sides by 2? If that by chance were a negative, I would have had to have flipped the signs. It wasn't, so we didn't have to worry about that, but understand that you may see that. Now, I'll get rid of that plus 6 by subtracting 6 from both sides, which it does. And x now is less than or equal to negative 12. Okay, so that's my inequality. Let's see what the graph looks like then, which for me helps me with the interval. So this would be 0. This one would be negative 12. I think I got the sign right on the 0. So I'll start with the red. I start with the red one, and x is greater than or equal to 0. So it could equal 0, right? So I'm going to fill this circle in. And that one's eating the x, so it goes to the right. With the negative 12, This one is, it could equal negative 12, according to the inequality. So I'm going to fill that circle in, and it's not eating the x, so it goes to the left. So these ones are going away from each other as well. The purple is showing that it would go from negative infinity all the way to negative 12 and stop there, but the negative 12 is included, so we got a square bracket. And then we'll unite this starting at 0, which is included, and that line goes all the way to infinity. So that there at the bottom is our interval. Okay, well, let's get started on this one here. So 8 minus 5 absolute value, 6x plus 3 should be greater than 9. Well, we got to isolate that absolute value, right? Again, I don't really care what's on the inside. I'm not going to cover it this time. But I really don't care what's on the inside because I just want to solve for it. Okay, which means that 8, I got to make it go away. And by go away, I mean become 0, right? So that's going to be subtract 8 from both sides. Now I'm left with, on the left side, negative 5 times the absolute value of 6x plus 3, even though I don't really care what's on the inside. Subtraction won't change the inequalities, and 9 minus 8 is 1. Next up, we are going to divide both sides by negative 5. Okay, so that's going to become a phantom 1, which we want, and I'm left with the absolute value of 6x plus 3, which is, oh, I divided both sides by a negative, by the way, right? So that, I'm going to emphasize the negatives there in green. That is going to flip the inequality from a greater than symbol to a less than symbol. And now we're comparing this with the fraction negative 1/5. Now you could, if you wanted to, you could solve this. But I really hope that you don't, because we can be done with this right now. Let's write this out so we can see exactly what's going on, all right? We're saying that the absolute value, this is showing us an absolute value that is less than, I'll emphasize the less than, a negative. I don't really care that it's negative 1/5, it's just that it is a negative, okay? Now, this should lead us to ask questions, okay? Can an absolute value be less than a negative? And the answer to that is no. Absolute values can never be less than negatives. So this one right here, it just automatically right now has no solutions.
Isn't it automatically that because it's a negative?
That's this scenario. If by chance, let's say that it flipped it in, and let's say that we had a greater than symbol here. So if the absolute value is greater than a negative, we hopefully know that the absolute values, since they're all going to come out positive because it's a distance, it will always be greater than any negative. And that would then in turn give us infinite solutions or all real numbers or something like that. Solve each inequality, graph the solution, and give interval notation, which we've been doing anyways. I like to use the graph for interval notation. So on the assignment, when you put the U in there, type a capital U, I guess. And if you need to use infinity, it's double letter lowercase o's. There you go. I don't care about that because I'm just solving this. So let's solve it. Okay. Well, we want to isolate that absolute value, right? So I'm going to get rid of that +1, so -1 from both sides. That zeroes that out, and I can drop my 6 times the absolute value of x, which is now greater than or equal to 19 minus 1 is 18. Then divide both sides by 6, which leaves me with the absolute value of x. We divided both sides by a positive, so it's just going to keep the absolute value the same, or the inequality the same. 18 divided by 6 is 3. Okay, now it would be nice if this was an equation, because it would be pretty close to being done, but we got some more work to do on this. We need to now take that absolute value and split it up, right? So I'm going to say x in comparison with +3, it would be greater than or equal to 3. And it's eating the absolute value, right? So I'm expecting an OR statement. But on the other hand, I can compare x with -3. It just flips the inequality. Okay, well, we have our inequalities. I thought we'd have would need a little bit more, but we don't. So look at our number line. Put 0 right in the middle, -3 on the left, +3 on the right. I'll start with the +3 just because it's on the left. So there's x is greater than or equal to 3. So it could equal 3, right? So I'm going to close that circle in. It's eating the x, so it goes to the right. It is an or statement, so we can unite these, right? And then we got the x is less than or equal to -3. So at -3, it could equal -3. So I got a closed circle there. This one's not eating the x, so it's going to go to the left. And now I'm ready for the interval notation. So over here, it's going to go from -infinity, which is never included. And again, on the assignment, you type in 2 lowercase o's. This goes all the way to -3, which is included, so I would have a square bracket there. And remember, on the assignment, you'll type in a capital U between these to unite them. And then the red line starts at 3, which is included, so square bracket, and this goes to +infinity. So on the assignment, double O, lowercase o, and then close it with the parentheses because those are never included. And we now have the graph and the interval. I guess we had the inequality, but I don't think it asked for it. No, it said solve the inequality. Okay, fair enough. So 3 parts. We solve the inequality, we have the graph, and we have the interval. I'm always cautious with these. Whenever I see something like this, my first instinct is to think that, well, you'll see. So remember, we don't really care about what's on the inside of the absolute value, right? So this time I will emphasize that I don't care about it, and I really hope you don't either. So I'm just going to cover that up for now. So I'll come back to it, I hope, if the technology will allow me to. Remember, we need to solve first, just for the absolute value. So I'm going to start by zeroing out that +5 there. So I'm going to subtract 5 from both sides. Okay, that zeroes that out. Now I got a -3 times some absolute value, which is less than 14 minus 5, which is 9er. And this is what I mean. There's something fishy is going on when something looks as ugly as it did. But now I'm going to take that -3 and divide it by itself to make it a phantom 1. But if I do it to one side, I got to do it the other side, right? So this one ends up being some absolute value. We divided both sides by this negative, so that's going to flip the inequality to a greater than symbol. But we now have 9 divided by -3, which is -3. Okay, so we're back at the kind of the original problem, or problem two problems ago, however many problems ago it was, where we're now saying an absolute value is bigger than a negative. That's always going to be the case. I guess the last one was that, so this one is a little bit different. So I guess I should explain here, right? So we're saying, again, I don't really care what's on the inside, but we need to be done with this one because we're now comparing an absolute value with a negative, which as soon as we compare an absolute value with an equal sign or any type of inequality, we should be done. Okay, so this is saying that the absolute value is greater than negative. Okay, so I'm going to reword the question here. When will an absolute value be greater than a negative? Question mark. And the answer to that is always. It will always be, because absolute values are always going to come out as positive. So remember how ugly that was inside there? It's still ugly inside. We just don't care about what's inside the absolute value. Just it's going to come out positive. And so this one ends up having just infinite solutions. Now you'll have to keep in mind, even let's say that, let's go back to the start here. Even if by chance they had the equal part on the inequality, it still doesn't change that there's an infinite number of solutions. And that would be true even if there were no solutions. If it said, hey, can you make this thing equal to it? It still doesn't matter. It should be no solutions there. So we will solve this one and we will graph it and put it in interval notation just to cover all our bases, okay? So on this one, first thing we need to do is solve for the absolute value, right? So let's get rid of that -10 by adding 10 to both sides. That zeroes that out just as we want it to. Now we have 5 times the absolute value of 9x plus 7, which is less than or equal to 40. And then we need to get rid of or make that 5 just a phantom 1. So divide both sides by 5. Now we're dividing both sides by positive. That's good. And then we're left with the absolute value of 9x plus 7, which is still less than or equal to, but now 8. All right, now that we have this inequality, we're going to split it up. You could write an and statement if you wanted to. Like, that's perfectly acceptable in my book. But really what we want to do is we want to sandwich that. But okay. Well, we're going to sandwich that 9x plus 7. Yeah, I don't know what's going on with the technology, but so we're going to say it would just be less than or equal. It could be less than or equal to 8. But now we also need to say that it could be greater than or equal to negative 8, okay? So this is one of those inequalities where you have to sandwich this between this value and its opposite because it's not eating the absolute value, okay? Now that we know that, let's solve this, okay? Now this is an inequality in 3 parts. I think they call them tripartites, but I also assume you don't care. Okay, so whatever we do to one of these, we got to do all 3. And we want to isolate that x and get it by itself, and we also don't want 9 of them. But I definitely don't want that plus 7 there, so I'm going to subtract 7 from not just both sides, but all 3 parts here, okay? So on the left, negative 8 minus 7 is negative 15. The 9x, of course, we can just drop. We zeroed out the positive 7, which was what we wanted, and then 8 minus 7 is 1. So this is not going to change the inequalities, so we're going to keep those. And then next up, the last thing I'm going to want to do here is to make that coefficient of x a phantom 1. Okay, so you make it a phantom 1 by taking the coefficient of 9 and dividing it by itself. But if you do it to one part, you got to do it to all 3 parts for this. So on here, I'm dividing all the parts by a positive value, so that's not going to change the inequalities. On the left, I got negative 15 over 9, which will simplify to negative 5/3. And then the 1 divided by 9 is just 1/9. And I'm going to keep the fractions here because the decimals are long and ugly, in my opinion. But, well, they're not too bad. So now I'm ready for the graph on this. So if I had 0 here, 1/9 is positive. I think I got that right this time. And then negative 5/3. Let's make these big again. Negative 5/3 on the left. And so with the negative 5/3, you could say that it could equal negative 5/3. That's okay. And then the 1/9 as well. But the x is sandwiched between, so it's just everything in between this. I should need a little bit more space for the interval. So starting at this graph starts at negative 5/3, which is included, and it goes all the way to 1/9. And that's where it stops, which is also included. So this is my interval right there. The graph, and we have the inequality too.